Okay, so let's see if we can answer these questions together. First question is, which version of OSPF is used in the topology? So all I've done is run a filter on this Wireshark capture for OSPF. So OSPF allows me to filter out the other protocols and only see the OSPF messages. What we're seeing here is a router with this IP address 10.1.3.251 and another router with this IP address 10.1.3.2 sending multicasts to the well-known multicast address of 224.0.0.5. So we see some hello packets, and then we actually see a message directly from one router to the other. We see continued hello packets, and then we get some database description messages, request messages, so link state request and update messages, database descriptions, and so forth. But just off these hello messages, we should be able to determine a lot of information. I'm going to go into a little bit more detail here. I hope that's okay, but I want to make sure that everyone understands how the protocol works. First thing, layer 2, notice source MAC address. Destination is the OSPF multicast address, so IP version 4 multicast. This is the MAC address for IP version 4 multicast 01005E. And then this portion, the last 23 bits actually, is determined by multicast addresses. The well-known multicast address, as we can see here, for OSPF is 224.0.0.5, so the MAC address is 000005. So multicast MAC address for OSPF. At layer 2, we see that the layer 3 protocol is IP version 4, so the type field is set to 0800. So IP version 4, source IP address, destination IP address, we can see once again. Here's an interesting field. Notice the DSCP, or Differentiated Services Code Points, is set to CS6, class selector 6. That is actually a higher priority than expedited forwarding, which is used for voice over IP. Routing protocols are deemed to be more important than voice over IP. In other words, this is some of the most important traffic that you can have on a network, and it makes sense. If you can't route, in other words, if routing protocols can't communicate and can't send routing updates to each other, you will not be able to forward traffic in your network, so everything else will break. So you need your routing protocols to be prioritized over other traffic types. So CS6, in other words, very, very important traffic in the network. But let's go down a bit further. I'll make the Wireshark window bigger. Notice protocol, OSPF, IGP. Protocol number 89. This is the well-known protocol number for OSPF. It's a good one to remember. So 89 is OSPF. Wireshark actually makes it easy for us. It's interpreting the protocol number automatically. Source IP address, destination IP address, once again displayed. This implies that this is OSPF. So in Wireshark at layer 4, we see OSPF. So layer 2, Ethernet. Layer 3, IP version 4. Layer 4, OSPF. There's a bit of debate whether OSPF is layer 3 or layer 4. We won't get into that debate, but essentially OSPF relies on IP version 4 in this case. So which version of OSPF are we running? It's OSPF version 2. So which version of OSPF? V2. We can see that clearly in the Wireshark capture over there. This is a hello packet. This is the size of the packet, so its length. This is the source of the message. This is actually the IP address of router 1. This IP address, 10.1.3.252, is the IP address of router 2. But for now, note, IP address of router 1, area ID 0000, backbone area. So we can actually answer this question as well. The backbone area, and I'll make this a different color, let's say blue. Area is, the area in this example is area 0. It can be written as 0, or it can be written like this. Same thing. Is it a router? Is it a router? Is it a tomato? Is it a tomato? Same concept. It's area 0. Okay, so checksum is correct. That means there's no problem with the packet. Notice here, authentication type is simple password. So, is authentication used Yes, it is. So authentication is simple. Simple password is used. Very bad idea. But that's what we've got here. Notice here's the password. It's OSPF pass. So that is the password. Not a good idea to use clear text protocols in a network. It's very, very simple to capture the passwords. There you go. There's the password shown clearly in the Wireshark capture. So be careful using clear text passwords. With OSPF, we actually want to use MD5, not clear text. Better to use MD5 passwords. Okay, another question. What are the OSPF router priorities? So let's dig down a little bit deeper. We can see the hello packet. Notice network mask. Notice here, priority. So this is router 1. If you didn't know the answer to that, you could just say the one router has a priority of 101. And if we jump to router 2, second router, notice its priority is 102. So router 2, 102. Very easy to read Wireshark captures if you understand the data or understand what you're looking at. Once again, you get free access to my CCNA course. So if you want to learn more about this, have a look at my CCNA course. But in brief, OSPF is a routing protocol run within an autonomous system. Router priorities for determining who's in charge of a segment is done based on router priority, one of the determining factors. Highest priority wins. Notice at this point we don't see designated router and backup designated router. There is an election that takes place. That election hasn't completed. So let's go right to the end. In other words, later hello packets once the routers started talking to each other. So notice here we've got no backup designated router. But if we go through the messages, you'll see they will negotiate a bunch of stuff. And then we should start seeing in the hello messages, like here, who the designated router is and who the backup designated router is. So who's designated router? The designated router in this topology is 10.1.3.252, as we can see over there. Highest priority wins. This router has a high priority, 102. So it's going to be the designated router. Okay, so I've answered all those questions. How did you get on? Were you able to answer these questions? The thing about Wireshark is you can dig really deep, but you need to understand the protocols. So you need to spend some time learning the theory of protocols. I mean, this means nothing if you don't understand what you're looking at. So you need to spend some time learning about OSPF. Once again, OSPF version 2. Later releases of OSPF, OSPF version 3, would be used in an IP version 6 environment. In this example, we're just looking at OSPF for IP version 4. If you don't understand what a backbone router is, it doesn't make any sense. It's important that you learn your routing protocols. So let's actually have a look at the consoles of the routers. There's router 1. Here's router 2. Just to prove that what I've explained through Wireshark is actually true. So show IP, and let's do the easy one. So show IP interface brief rather. You can see this is the router's IP address on gigabit 01, this interface here. On router 2, show IP interface brief. This is the IP address on gigabit 00, this interface. Show IP OSPF neighbor. Notice this router, router 1, has a neighbor relationship with router 2. We can see that it's a full relationship. The other router, in other words, router 2, is the designated router per what we worked out in Wireshark. So show IP interface brief on this side. Make that bigger. Notice, that's the wrong command, sorry. So show IP OSPF neighbor rather. So router 2 sees router 1 as a backup designated router. Full relationship on a Ethernet segment. The designated router and backup designated router form full relationships with other routers. In other words, they exchange the topology database with other routers. And we can see that over here. Notice we've got hellos, and then we've got a database description. So in the output here, we can see a description of the database. So some information about the database is shown in the capture. So we see some information about the database, but the one I want to point out is, notice as we go down, we've got a link state request message, and then we've got a link state update message. Notice LSA type 1. So if you've learned a bit about OSPF, you'll know about LSA type 1, 2, 3, 4, and 5 as an example. Notice we can see network information. This is a stub network, 10120. Here's another stub network, 10130. This was advertised by 1013252, which is actually router 2. 10130 is the segment between the routers. Notice you can see 10130 something being advertised here. This network is 10120. And we can see that once again over here. 10120 is the subnet on this interface, gigabit 01. If you actually want to see that, we can do it this way as well. Show run interface gigabit 01. Notice this is the configuration of that interface. And if I type show run or show IP interface gigabit 01, you can see the IP address and the subnet mask on that interface. Okay, so we can see here the networks that are going to be advertised by the two routers to each other. Here we see a database description. Here's another update. So basically the routers are communicating information to one another. This is router 1. Notice 251. Different network is shown here, 10110. So we see 10130, that's the network between the two routers, and 10110 advertised between, or should I say from router 1 to router 2. We can see the metric or the cost to get there. So network, subnet, metric of this network. It's a stub network. In other words, there's no other router connected to this network. A lot of information can be gleaned from Wireshark. You see acknowledgements. OSPF doesn't rely on TCP. So if you have a look here, there's no TCP protocol. If it sends a link state update to the other router, it needs an acknowledgement back to make sure that the other router got to the update. Otherwise, it's going to retransmit that data. Because there's no TCP to do the retransmissions and make sure the data gets through, OSPF has its own mechanism to do that. And you can see that once again through the Wireshark captures. Link state update, link state acknowledgement. So the one router requests data, the other person updates, and then we give back an acknowledgement to make sure that it got through properly. Or acknowledge to the other person that we received what they were sending us. Again, Wireshark is brilliant. You can see so much information just by looking at a capture. There are other protocols running on this network. We can see broadcast here, so ARP. We can see spanning tree, other protocols. But by simply searching for OSPF, we can see the OSPF messages and then interpret what's going on. Again, how did you get on? If you weren't able to answer the questions, don't worry. Just learn. Learn Wireshark. It will help you tremendously in the real world. It's an important skill for any networker to have, or anyone interested in sort of ethical hacking. You want to be able to learn what's going on in the network. And by simply running a sniffer like Wireshark, you can actually see a whole bunch of stuff on the network.